Hello, today I'm going to talk about empirical formula. Let's start with some example. Our first example is C6H6, that is benzene, and we can see that was a ratio from of carbon to hydrogen, and we can see that it's 1:1. So C and H. So for 6 carbon, you have got 6 hydrogen, so the ratio is 1:1. So that is the empirical formula. That is the empirical formula. Another example is C4H10, that is our butane, and in butane we can see that for 4 carbon we have got 10 hydrogen, so cancelling it out so that we could reach the lowest whole number ratio, and we get that for every 2 carbon we have got 5 hydrogen, and it is C2H5. Okay, that is our empirical formula. So from it we can say the definition of empirical F of formula. Empirical formula as the ratio between the atoms, over here carbon hydrogen atoms of all the elements, all okay, let's let be all the different elements. So what are elements over here? Carbon, hydrogen in this case also carbon, hydrogen. We can take one more. Let's take H2O2, hydrogen peroxide, H2O2. So the ratio is 1:1, and this is the molecular formula, and this is the empirical formula. In H2O, we can say that molecular formula and the empirical formula are the same. Okay, so are the same. The ratio between the atoms of all the different elements, so in each of the cases we can see the different elements present in one molecule of a compound, different elements present in one molecule of a compound. Okay, so that is empirical formula. Let's take one example. How can we find the empirical formula? So we'll start it with a reaction of oxygen and hydrogen, OXYGE, and oxygen plus hydrogen. I'm deliberately not writing the the the, the formula for oxygen and hydrogen. Gives us water. So suppose a chemist takes oxygen and hydrogen, and he reacts both of them, and he got water. So what he did, he took 8 grams of oxygen and 1 gram of hydrogen, and when he reacted it, then he got 9 grams of water. So it tells you that 8 grams of oxygen completely reacts with 1 gram of hydrogen to give 9 grams of water. So from this we can analyze something, that the number of atoms present in 8 grams of oxygen reacts completely with 1 gram of hydrogen. Okay, so but how will we know how many atoms are there in 8 grams of oxygen and how many atoms are there in 1 gram of hydrogen? So we have to convert 8 grams into number of atoms, and we know that to convert grams into the number, we have to divide it by the gram atomic mass of that atom, and over here it's 16, so we get half a mole of oxygen, half a mole. And for hydrogen we get the same thing, we get 1 mole of hydrogen over here. Okay, now from this, how can we know what is the ratio between the atoms? And it's very simple. It's telling that for every 1 mole we require 0.5 mole. So from that, for every 1 atom of hydrogen we require 0.5 atoms of oxygen. Converting that into whole number, we can multiply it by 2 and we get 2 and 1. So for every atom of oxygen we require 2 atoms of hydrogen, and we get the empirical formula as H2O. Okay, so let's do that in a table form, because in the books it's been shown in a table form, that but this thing makes more of a sense than the table itself. So let's take the element, and we have got oxygen and hydrogen, and the masses of which are 8 grams and 1 gram. Many a times you would see that percentage mass is given, mass percent or percentage mass is given over here, so that is also not a problem. So suppose that if this 8 grams, actually percent means something in 100. Out of 100 grams, what gram is of oxygen and what grams is of hydrogen? Out of 100 grams, over here we have got, say, 9 grams of the sample, means combined oxygen and hydrogen combined. In the same way, out of 100 grams we can say that the same oxygen will become approximately 90 grams out of 100 grams, and the hydrogen will become 10%, nearly, approximately. Okay, so instead of, when we get the percent, we'll take just as 90 grams over here and 10 grams over here, convert that into moles, we'll get the value of moles, 9 times higher over here, and how many times higher over here? So whatever times, we need to find that. So higher over here, but the ratio would be the same. Okay, so we have got the mass over here and the moles. So what we get over here is 8 by 16, 8 by 16 and 1 by 1, that is our 0.5 moles, and it's 1 mole. Then we have got the simplest ratio. Our simplest ratio is 0.5 by 0.5 and 1 by 1. We get 1 over here and we get 2 over here, so the ratio becomes H2O. Okay, thanks for watching the video.